In this video, we're going to work on basically translating a lot of the formulas that we have for linear functions so that they're written with function notation. And for some that looks like a very small thing, and for some that looks a lot more complicated. But this really, I think, is our biggest goal in this class with function notation, is to get good at the translation part, to be able to read things with function notation and have you recognize them as the same thing that we saw without the function notation. So the first one is our slope-intercept form. Slope-intercept form in an algebra class, we're typically given y equals mx plus b. And the only thing here that changes with function notation is that the y is replaced with an f of x or g of x or whatever function name you want to use. So we name our function is the big thing for slope-intercept form. One other small thing is that we can describe y-intercept with function notation. We don't have to, but since that's kind of what we're practicing, I went for it. So slope-intercept form is f of x equals mx plus b, where m is the slope, and instead of just saying b is the y-intercept, I can say b equals f of 0. B is what you get when you plug 0 into the function, or in other words, the function goes through the point 0b. So this is the same as saying that b is the y-intercept, because when you look at this, you should translate that in your head to the y value that we get when x is 0. So again, the 0 in the parentheses is your x value. F of that will give you the y value, so b is your y value. When x is 0, y is b. Okay, so lots of kind of confusing talk there, but that's the idea, is just for you to recognize what this means. Slope looks a lot different, and this is a really important one. We'll come back to it in pre-calc, and it's the foundation, again, of what we're doing in Calculus 1, rates of change. So for a linear function, the rate of change is constant, and we name it the slope. The slope is the constant rate of change. And if we write that in function notation, we actually already saw this. It was the average rate of change formula, but I just wanted to bring it back up again here. The slope of a linear function, we generally see as y2 minus y1 over x2 minus x1. So if we wanted to use the x1, x2 notation, function notation would just look like f of x2, the y value at x2, minus f of x1, which is the y value at x1, over x2 minus x1. But I switched it up a little bit more, went for this AB notation, because we kind of move away from using that subscript in our average rate of change formulas and in calculus. So really I've just named x1a and x2b. I've just replaced them. And that's what the slope formula looks like. So I think, again, the really big thing here is whenever you see f of something, you're thinking y value. So that when you read this fraction right here, you say, okay, the y value at b minus the y value at a over b minus a. And I guess I should emphasize as well that b minus a I am reading off as x values, but I think the y values are the big ones that are a little new and weird. And then last but not least, point slope form. It looks, I think, extra crazy. So just remember that point slope form, we're usually given as y minus y1 equals m times x minus x1. So again, I'm shifting away a little bit from the x1, y1 notation. Not that there's anything hugely wrong with it, but really the subscript 1 is kind of taking the place of what function notation does for us. So we'll just say x1 we're going to call a, and if we want the y value at that x, we would just plug into f. So we're just replacing x1 with a, y1 with f of a. And then just like in slope-intercept form, we replace y with f of x. So it might look crazy, but it really is the exact same formula. Again, there's one other piece of information that I can rewrite with function notation. Normally we'd say m is the slope of the line and x1, y1 is a point on the line. But now we can say a, f of a is the point on the line. And this just really helps us focus in on we're being given one x value and we're building everything around that. So x equals a is the only specific thing we need to say because the y gets represented as f of a. Okay, so that's looking at your linear functions formulas with function notation. And to practice this a little, we're going to move into next having some problems where you're given information in function notation and asked to find the equation for the line. So the finding the equation piece should just be review. Reading that information out of function notation is what's the new piece.